We're having here the equation which is third order differential equation. We are going to discuss that how we can solve this differential equation, and this is non-homogeneous with the constant coefficients. I have made the coefficient of y triple dash equal to 1. If it is this not 1, then we have to make it 1, and then we can identify our f of x. The steps are the same as we did in the last one. That number 1, we find the homogeneous part of the solution of the differential equation. Then we defined our u1. Here there are u1, u2, no u1, u2 and u3, and find u1, u2 and u3 by the help of Cramer rule. Let us see here. So we discussed the method for this one. Step 1 is the method is variation of parameter. Step 1 is to find yc. So our differential equation is y triple dash plus p y double dash plus q y dash plus r y equal to 0. We solve here by using here let y equal to e power mx. I get here yc is equal to c1 y1 plus c2 y2 plus c3 y3. Now I want to find yp, or your general solution will be y equal to yc plus yp, and here we use the variation of parameter to find. This is my part 1, step 1. Step 2 is to find yp. Now I substitute, I take this one, my yp is equal to u1 y1 plus u2 y2 plus u3 y3. Now I have 3 unknowns, so u1, u2, u3. We substitute this equation in our general equation form, compare the coefficients, we get 3 equations. In u1 dash, u2 dash, we get here y u1 dash plus y2 u2 dash plus y3 u3 dash equal to 0. Second equation is y1 dash u1 dash y2 dash u2 dash y3 dash u3 dash is equal to 0. And here now we get y1 double dash u1 dash y2 double dash u2 dash y3 double dash u3 dash is equal to f of x. So those of the students who are really bright and check the changing problem, you can derive this equation by substituting the value of yp in the equation and then comparing the coefficient. You will get this one. Now here from these 3 equations, you'll find here, as we did in the before, you'll find here u1 dash, u2 dash and u3 dash. We use Cramer rule, or u1 dash will be equal to w1 over w, u2 dash will be equal to w2 over w, and u3 dash will be equal to w3 over w. We integrate it, we get the value of u1, u2, u3, substitute here in this equation, and that will give you the yp. Then we are having the value of u1, u2, u3, you will get here your yp is equal to u1 y1, u2 y2 and u3 y3. Once you get it, you can write your general solution. The general solution in this case will be, as before, the linear combination of yc and yp. The steps are same. Only the thing is that here the third order differential equation, and when we find here w, I will give you the example to explain this one. I give you the example. We want to solve this equation y triple dash plus y dash is equal to tangent x. It's third order differential equation with a constant coefficient. The coefficient of y triple dash is equal to 1. So this is my f of x. And this is the form where I can't apply undetermined coefficient. The part 1 is same as I say. We find our yc, the homogeneous part of the solution. To find yc, we write here y triple dash plus y dash equal to 0, and we solve here taking y is equal to e to power mx. We get the characteristic equation. In this case will be m cube plus m is equal to 0. We take m common. I get here m square plus 1 is equal to 0. So I have two roots are my m equal to 0 and m squared plus 1 equal to 0. That means m is equal to plus minus I, the complex roots. I can write my yc. My yc is equal to c1 e to power mx, e to power mx is e to power 0 is equal to 1, plus c2 alpha is 0, c1 cosine x plus c2 sine x. So this is my yc. Now part 2 of my problem is to find yp. To find yp, as we discussed before, now my yp will be equal to c1 u1 y1 plus u2 y2 plus u3 y3. Here I have to find u1, u2, u3, and my given to me is my y1. My y1 is equal to 1. My y2 is equal to cosine x, and my y3 is equal to sine x. And I'm also given with the tangent with f of x. My f of x is equal to tangent x. So as before, I find my w, w1, w2, because here my u1 dash is equal to w1 over w, my u2 dash is equal to w2 over w, and my u3 dash is equal to w3 over w. We defined our w. Our w is equal to the determinant. I'm having y1 cosine x, sine x, and then I take the derivative. If this is 0, is minus sine x, cosine x, again taking derivative 0, minus cosine x, and minus sine x. Open from the first column, having 1 into the second determinant 2 by 2 cosine x, and here is minus cosine x minus sine x. Other values are 0, so we solve it. We get here sine square x plus cosine square x, as we used before, is equal to 1, is not equal to 0. So once I get my w, I can write w1, w2, and w3. In w1, I replace first column by 0, 0 f of x. w2, I replace second column by 0, 0 f of x. And w3, we replace third column by 0, 0 f of x. We solve this one. We solve here, we get here tangent x. And we open from the first column. We get here into cosine square x minus sine square x. And we having here into cosine square x plus sine square x. We know sine square x cosine square equal to 1. So we get here the value of w1 is tangent x. We come here and again open from the first column. So this is gone, this is gone. Here we multiply these two. We get here minus tangent x into cosine x. Now tangent x is minus sine x over cosine x into cosine x. So cosines cancel cosine, we get here minus sine x. This is the value of w2. Value of w3, we open from the first column, this is gone, and get here minus sine x over into tangent x. Now again we substitute, we having here is equal to minus sine x, and tangent x is equal to sine x over cosine x, and this is minus sine square x over cosine x. Now we know sine square x is equal to 1 minus cosine square x. We are having this identity that we are having here sine square x plus cosine square x is equal to 1. Then sine square x is equal to 1 minus cosine square x. We get here minus sine square x. And we get here cosine square x minus 1. So I write it here. I'll get here this equal to, this here we'll get here 1 minus cosine square x over cosine x. So that will give me 1 over cosine x in minus cosine square x over cosine x. So you know this is equal to secant x and minus cosine x. So this is, I get here w1, w2, and w3. Now I can write here my u1 dash. My u1 dash is equal to w1 over w. That's my w1. w1 is 1. w1 over w. That's equal to 1 over What's my W? W1 is tangent x. W1 is tangent x, and W is equal to 1. This is my tangent x. Then what's my U2 dash? U2 dash is equal to W2 over W. What's my W2? My W2 is equal to here minus sine x over 1 is equal to sine x. And U3 dash is equal to W3 over W. W3 is secant x minus cosine x over 1. We get here secant x minus cosine x. So I get here the value of W1, W2 and W. Now I want to find the value of U1, U2 and U3. I just clean this part of the discussion. We have already used this one, and we come to the integration to get the value of U1, U2 and U3. So I integrate here both the sides. I get here U1 is equal to integral, I have tangent x, this is equal to into dx is equal to ln of secant x. I want to convert into cosine. This minus ln of cosine, because having cosine in between, so that's why I'm using this one. Then U2 dash, we having integration of this one, both sides, is minus sine x into dx. Integral of sine x is minus cosine x, minus plus. We get here cosine x. We take derivative of cosine x minus sine x. U3 dash, integral of, we're having in secant x minus cosine x into dx. And the integral of secant x is equal to secant x dx minus cosine x dx. And this is your ln of secant x plus tangent x. Okay? You must remember the formulas for integration. Minus, we get here sine x. Integral of cosine x is sine x. Now we substitute the value of u1, u2, u3 in our equation here, that we are having here the value of y1, y2, y3, and this is my value of y1, y2, 3. I can write yp is equal to u1 plus y1 is 1, u2, yt is cosine x, u3, y3 is sine x. Now I substitute the value of u1, u2, 3. Value of u1 is ln of, so having here ln of minus ln of cosine x plus u2. u2 is cosine x, and we having here cosine x into cosine x is cosine x into cosine x plus u3. u3 is we multiply this with sine x. We get here ln of, we multiply with sine x. We're having sine x into ln of secant x plus tangent x, and then multiply minus sine square x. We have a small mistake here. This is the minus sign because we replace sine square x is 1 minus cosine square x. This become minus and this become plus. So this way become minus and this become plus. So we have a small change here when we do it, that we having the integral of this one is minus and we get here plus. So similarly we will get here minus sign and we get here plus sign. So that is a small change we have made. We are having here cosine square x into cosine square x, that's equal to 1, and we use this one. We have here cosine square x plus sine square x is equal to 1, and then we have 1 minus ln of cosine x, and then we have plus, not plus, it's minus sine x into ln of secant x plus tangent x. So that's my yp. So when we want to write my y, then as we have mentioned before, my y is equal to yc plus yp. So we can write this one as yc plus yp. Here we can write our solution. Our general solution will be is y equal to yc plus yp. We're having here yc is equal to c1 plus c2 cosine x plus c3 sine x. Then yp, or yp is here, we say 1 minus ln of cosine x, then we having minus ln of, then minus sine x into ln of secant x plus tangent x. Again, there is some more example in my notes, so you can just go to the notes and check this example. Otherwise, we'll take long time to complete this one. Thank you very much.